This is Learning Assessment Problem 1017. The problem-solving strategy here is that of circuits containing ideal transformers. In this problem, we have a network containing an ideal transformer, a voltage source, and other circuit elements. For the ideal transformer, we have the relation that the turns ratio N is equal to 2. And because of the relationship of the dots on the transformer and the polarities indicated for the voltages and currents, we have that the voltage V2 is equal to minus 2V1, and the current I2 is equal to minus I1 divided by 2. We'll begin by analyzing the circuit using node equations to solve for the voltages V1 and V2. We'll choose as a reference node the bottom of the circuit here. So KCL at the node V1 voltage gives us, or we can combine terms and have that V1 times the sum of, here this term that multiplies the V1, this 2 over 2 ohms comes about from that negative V2 term in the summation of the currents and the relation for the V1, V2 in the ideal transformer. Now we can compact this a bit more, combining some of the terms multiplying V1 and obtain 2.5 V1 plus I1 is equal to 5 at an angle of 0 degrees amperes. Now we'll proceed to write a nodal equation at the node voltage V2. Here we'll sum the currents at the node V2. And again we can rearrange terms and relate the V2 and I2 quantities to the corresponding V1 and I1 values with regard to the transformer relationships. And then rearranging this expression, we obtain a KCL equation at V2. So this will be our second node equation. Now we'll put these two node equations into a matrix format. So this is our matrix equation resulting from writing the two nodal equations. The determinant of the admittance matrix is, or in the polar form, the determinant delta is equal to 2.926 at an angle of minus 19.98 degrees. Now we can solve for I1 using Kramer's method. And we can write this I1 expression as, and the current I1 is equal to 3.08 at an angle of minus 13.71 degrees amperes. The current I2 will be a little bit easier to determine. I2 is equal to minus I1 divided by 2 from the transformer relationship. And this will equal, or I2 is equal to 1.54 at an angle of 166.29 degrees amperes. We can again use Kramer's method to determine the voltage V1, or V1 is equal to 0.854 at an angle of plus 19.98 degrees volts. Then again, by the transformer relationship, we can write that V2 is equal to minus 2V1, and this will equal to an angle of 180 degrees times 0.854 at an angle of plus 19.98 degrees, or V2 is equal to 1.708 at an angle of 19.98 degrees volts.